Hello students, the part 3 of the lesson Quadrilaterals is here. What is this? Have you ever heard what is ethnomathematics? The beauty of the quadrilaterals and the polygons, they are all around us. We can see in our real life plenty of polygons around. You must have already seen these rangolis and any drawing which is collage art which has polygons, right? Certain buildings, they have structures or decorations in the form of polygons. The actual architecture in the building also can be using many polygons. You have to observe and list where are these found, okay? The last concept which we studied was angle sum property of quadrilateral. A four-sided polygon is quadrilateral. It has angle sum equal to 360 degree. We studied that, right? So using that, few more sums let us solve. So these problems, they are almost similar to your textbook first exercise. So I hope you have already studied that. You have to go through and whatever is solved here, if it is very similar, you must try that exercise question yourself, right? Okay, let me take up this problem. In the given figure, ED and EF are perpendiculars drawn from BA and BC. Okay, ED is this. Just now I highlighted that. It is in red in color and EF is green in color. You can see that now. They are perpendiculars. What do you mean by perpendicular? A perpendicular is the line segment which makes 90-degree angle with the given line. So perpendiculars drawn on BA. So ED is drawn on BA and EF is drawn on BC. So the green one is drawn on BC and red one is drawn on BA. Okay. So if one of the angle is given, angle B is given as 50 degree, right? It's given as 50 degree. We are asked to find out DEF. So DEF is appearing to be one obtuse angle. We have to find that DEF. So perpendicular means 90 degree. So already 90 degree is marked. It need not be written. Correct, no? So now observe the figure carefully. You can see the quadrilateral DBFE. DBFE is a quadrilateral. Correct, no? So start from that point where perpendicular is made, that red dot, vertex D, DBFE, and write all the angles of that DBFE. Angle B, angle D, angle E, angle F. So angle B is 50 degree, angle D is 90 degree, and F is 90 degree. Only left out is angle E. So you can see now, three angles are given, 90, 90, 50. These are given, correct no? So 50 also. Let me write it. Okay. So 50 is seen now. 90, 90, 50 is given. Only one of them is not given. So you have to find that. Find that angle E. So add these three, subtract from 360. So the same is written in detail. 50, 90, 90 added is 230. And that should be subtracted from 360 degree. You will get it as 130 degree. As we see it, it's obtuse angle. Correct, no? DEF. You get it 130 degree. So write the result. You will be correct. We have here one more question. Observe. Let me read the question. In the given figure, OC and OD are bisectors. Bisector means OC. OC, that line segment cuts angle C into two equal parts. Full angle C into two equal parts. Angle C is which one? Full angle, not that 45 alone. So you should see DCB, that is angle C. DCB is angle C and ADC is angle D. So that is cut by the bisectors into two equal parts. Observe here. That is angle C. I have shown now using red color. Full angle C of the quadrilateral ABCD. See, angle D also I have marked now using red color. That is full angle. So, if DO or OD is bisector means that full angle is double that 35. Am I clear? 35 is marked, no? That angle D is double 35 because bisector means OD cuts that red marked angle into two equal parts. Means what is given is half of that ADC, half of the marked angle. Therefore, angle ADC is 70 degree, angle BCD is 45 into 2, 90 degree. We can see that L shape, isn't it? That is also picture is correct, but we cannot rely on picture. 45 plus 45, 90 degree. So, we have to now use angle sum property once again. Angle A plus angle B plus angle C plus angle D is equal to 360 degree. So, angle A is 115, angle B is not known, angle C is 90 degree, angle D is 70 degree. So, togetherly we have add all, we should get 360, no? Angle A 115, angle B, angle C, angle D. So, find angle B. That comes out as 85. Okay, I hope I am clear. Angle A 115, marked two red angles and then angle B. Together 360 degree. Yes. Next question. This one we have solved in the previous class. We had one such question, I remember, where ratio was given 4 angles or at least 3 angles were given, I think. So you should be knowing it. You have to write it as 2x, 3x, 4x, 6x. So togetherly it is 15x degree. 15x degree is 360 degree. So x degree means angle x will be 360 degree divided by 15. So we can add no all those 2 times, or you can use here ratio method also. Add all the terms 2, 3, 4, 6, 15. 2 by 15 of 360 degree. That way also you can calculate. 3 by 15 of 360 degree. Similarly, 4 by 15 of 360 degree, 6 by 15 of 360 degree, like that. So I hope you understood this. 4 angles of the quadrilateral, where 3 angles are given. We had done that, I think. So you are you with me? Okay, in the previous class, whatever is explained, in case you did not understand, you should communicate, children, okay? Now, there is one more question which is very, very similar to this question in your textbook. In your textbook, I could see a similar question. Here, if you observe quadrilateral ABCD is given, C and D are given 160 angles. But in your textbook, they have given angle C and angle D, that one of the set is supplementary. They have given it as supplementary. What do you mean by supplementary? If they give it as supplementary, they add up to 180 degree. So here they are adding up to 160 degree. So in your textbook, I could see they are supplementary. So you should be able to do that. Or if they togetherly give C plus D is equal to 100 degree, that is also okay. If they give supplementary, it is 180. Now come to angle A. Angle A is what? Angle B is what? Angle A is actually double that. AP is bisector. So you can see here, I have shown now. AP is angle bisector, means now that whatever red marking I am showing, no, that is equal to angle PAB. See this angle. Angle PAB and the first whatever red marking, they both are equal. Therefore, we should mark it as those two are equal. Okay, now see this blue marking angle PBA. Just now whatever I highlighted. What is it equal to? PBC. Yes, like this. So these two are equal. That is the meaning of bisector. PB bisects angle ABC. PA bisects angle DAB. That is the meaning. PA bisects DAB. That is why those two red markings equal. PB bisects ABC. Two blue marks equal. So sum of the angles of a quadrilateral is 360 degree. We know that A plus B plus C plus D is 360 degree. So until we are not knowing now angle A and angle B, so write it as angle A and angle B. You can see here sum of the angles of a quadrilateral is 360 degree. I have written. Therefore, angle A plus angle B plus 60 degree plus 100 degree, 360 degree. So A plus B is 200. That's what we come to know. A plus B is 200. So half of A plus B is 100 degree. Correct? No? If A plus B is 200, half of A plus B is 100. I have written that as equation 1. Now, just to observe the triangle APB. APB. Half of A plus B is one red cut and one blue cut. In the marked angles, one red plus one blue is 100. That's what is half of A plus B. So if that is 100, the angle P should be 80 degree, because we know that in any triangle angle sum is 180 degree. Correct, no? So you have to understand that. You can see one red cut and one blue cut angle, marked angles is 100 degree, because they are equal. Two red cuts, two blue cuts, together 200 means one of them is 100. That is the angle of the triangle PAB and PBA. So it is 100 means angle P is 80 degree. So we come to the conclusion that angle P is 80 degree. This is the method. Very similar to this, there is a problem in your textbook. So you have to, there it is given that together angle C and D is 100 degree. So now you should be able to do that. Instead of 160, you have to 300 minus 100 directly. 300 minus 100 minus 60 you don't need to do. 360 minus 100 directly. So 260 you will get in place of A plus B. A plus B will be 260. Half of A plus B will be 130. So you will be able to find the angle P. Okay, let me proceed. There is a question here. A quadrilateral can a quadrilateral have four acute angles? You have to determine it yourself. Acute means all less than 90. 80, 80, 80, 80. Is it okay? Will it be 360? No. Is it 4 obtuse angles? Won't it be more than 360 degree? You need to think about that. I have given one example there. One quadrilateral is written. Just imagine two right angles, two obtuse angles. Is it possible? 90, 90, 100, 100. Will it be 360 degree? Answer is already written. 3 obtuse angles it can have, but not 4. Remember that. 3 obtuse angle, 1 acute angle is allowed, but not 4 obtuse angles, 4 acute. 4 right angles it can have. Correct, no? Okay. Now, here is a small activity. In your geometry box, you must have seen set square, one triangle kind of instrument, mathematical instrument that is called set square. So, you have to make a trapezium using that. Trapezium. A trapezium has only one pair of opposite sides. It's a special quadrilateral with one pair of opposite sides. So AB is parallel to CD. Is it not like rooftop of the house? Imagine a rooftop of the house. Or if you put it upside down, ulta, then it will become boat. The line which is parallel, the pair which is parallel is the top of the boat and the base of the boat. Those are the two parallel lines. Right? So AB is parallel to CD. So using that set square, you can make, but you need 3 geometry box for that. Do you have 3 geometry box? One box has only one, no. Set square, this kind of set square only one is there. Another is isosceles set square. So using this, if you get 3 similar, it should be same brand geometry box. Otherwise, you will not be able to make. So you can make this. Say, imagine it is 3 centimeter, 4 centimeter, 5 centimeter right angled triangle. You can make it like this. I will give you one more idea. If you want, you can cut chart paper of the same size, 3 centimeter, 4 centimeter, 5 centimeter. Then you can make it like this. But observe the next slide. It is not only like this. We can do it in different ways. If you have this kind of 3 centimeter, 4 centimeter, 5 centimeter triangle, congruent means they should be exactly same in size and shape. Only one shape, size and shape, triangle shape, size 3, 4, 5 only. Okay. So you should measure 3 and 4, form a L shape and draw the other side, third side. Then get such 3 triangles and then exactly same sized triangle. Congruent means that, you know that, you have studied. So next slide you see, I have done 3 different ways. This also I have done, but in addition, there are 2 more. See, it's very, very interesting because when you do it, you will realize. You can put it ulta, you can turn it, you can flip it. We say kauchi hakudu in Kannada. Just makchi haki. You will get it 3 different ways of trapeziums. Observe, they are all different. Though I used same set square, same sized set square, I am getting 3 different trapeziums. Remember, trapezium can be like this also. It need not be only rooftop. In the previous page, we saw only rooftop, the bottommost trapezium, right? Whatever I have made here, bottommost. But the upper two also are trapeziums. Because it has only one pair of opposite sides parallel, it can be drawn like this also. All these are trapeziums. You have to do it yourself. Please do it. You will learn and remember it forever. Okay. Now, how to name the parts of the trapezium? Let me quickly tell you. Observe, I have shown here one of the trapezium as LAMP. If I name it lamp, which gives us brightness, lamp, LAMP. In this, AM is parallel to LP. AM is parallel to LP. Other side, AL and MP are compulsorily not parallel. That is the main thing in a trapezium. In any trapezium, only one pair of parallel sides, opposite sides parallel. Other side is not parallel. Other opposite sides are not parallel. So AL and MP are not parallel. AM and LP are parallel. So we have something called this. See, observe. I have marked now two angles. Did you see now? That time it was not there. Now angle appeared. Angle A and angle L. These are called co-interior angles. These are called co-interior angles. Consecutive interior. They are on the same side of the transversal. Right? AL is the transversal. We have studied that. AM and LP are parallel lines. AL is the transversal. So, these are called co-interior angles. They are adding up to 180 degree. That is why angle M and angle N together, I have named it M, angle small n together 180 degree. And these two now. Observe, I am giving now two more co-interior angles. See, marked in blue. Angle B and angle A. I don't want to say that angle is three letter naming and all. I can give small letter also inside the loop. So angle A and angle B together. That is also 180 degree. Remember this. It is important for a trapezium. Co-interior angles. They are the angles which are on the same side of the transversal. So angle A and B are co-interior, M and N are co-interior, and all are angles of the trapezium. These are all called angles of the trapezium. Okay, both the marked red ones and blue ones. That we have studied angles of the quadrilateral. Okay, now I have written some important features or properties of the trapezium. Observe, opposite sides and angles are not equal. You will learn in detail about parallelogram. That time you will come to know. In parallelogram, opposite sides and angles are equal. But in trapezium, it is not like that. And in trapezium, only one pair of opposite sides are parallel, as I said. Only one. Two pairs are not there. That upper one arrow is there, no? AB line segment has arrow. That means it is parallel. CD and AB parallel. Similarly, PQ and S are parallel. Interior angles on the same side of the non-parallel sides are supplementary. Interior angles, just now I showed co-interior angles in the previous slide. I hope you understood. One pair I showed in red, another pair I showed in blue. So interior angles on the same side of the non-parallel sides. Okay, non-parallel side is the transversal actually in this. AD and BC are transversal. They are the non-parallel sides. Okay, adjacent means like how we used to say adjacent here, opposite means opposite. So parallel means parallel. Non-parallel means opposite of the non-parallel. Parallels opposite is non-parallel. So AD and BC non-parallel. AB and CD parallel. In the below trapezium, PQ and RS parallel. PS and Q are not parallel. Now, what is this isosceles trapezium? You can see here white trapezium. It is isosceles. Isosceles triangle means two sides are equal. Same way, isosceles trapezium means two sides are equal. Non-parallel sides are equal. You can see that. If non-parallel sides are equal, you will come to know that It is called isosceles and it has some special properties. Angle S will be equal to angle R. Okay, remember that. You can see that wide angles both are obtuse. In the PQRS isosceles triangle, S is equal to R and angle P is equal to angle Q. Okay, that is only special for isosceles trapezium. Only one pair of opposite sides are parallel. That is true for every trapezium. So, in this specially, angle S and angle R are equal. Angle P and angle Q are equal. That is why they have mentioned angles on the same base are equal. Same base means if I consider RS as the base, they are equal. S and R are equal. If I consider PQ as the base, P and Q are equal. Diagonals also equal. You can observe this. RP is same as QS. Diagonal RP is same as QS. And also a pair of non-parallel opposite sides. That is first of all I marked no PS and QR are equal. Then opposite angles are also supplementary. In the sense angle S and angle Q together 180 degree. Remember that because their S is same as R and Q are supplementary otherwise also. In any trapezium, R and Q are co-interior. But here S and Q also are supplementary because R is same as S. And RP is also, R and P, both angles are supplementary. S and P also supplementary. Remember that. So I have shown that angles, co-interior angles, two red angles, just now what you see. See, co-interior angles. Yeah, here these two are equal. So I have marked double marking, double loop, double loop. They are equal. And here now green, these are equal. In the trapezium PQRS, these are equal. And the two red marked are, they are equal. Observe it. Okay. This is a small activity. If you cut three equilateral triangles, you can join those pieces like this. That time I said you can cut the set square kind of triangle and join. Now you can cut this also and join. It becomes isosceles trapezium. Okay, a boat or rooftop. Three equilateral triangles. You can try that. It's given in your textbook. This is from the textbook. First question of the textbook. Okay, so it says trapezium PQRS. In that they have given PQ is parallel to RS. Now they don't need to say anything about the PS and RQ, remember. Only one pair is parallel. When they say trapezium, PQ is parallel to RS. It is given. And I have shown angle P 70 degree, angle Q 80 degree, all that. Angle R and angle S is to be found. We need to find that. So use this co-interior angles property, okay? Co-interior means, I said no. Interior angles on the same side of the non-parallel side. SP and RQ are non-parallel, not parallel. So they are together, no interior angles on the, or they are also called co-interior angles. We always call it co-interior. It is easy to name it. So 70 degree and that S together, P and S together is 180. So how much should be S? 110. Same way, R and Q is 180 together. So R is 100. Simple. Okay, it is together it should be 180. So you should find 180 minus the given angle. Okay, next question. This is a simple question given in your textbook. I feel that there is something which is missing here. Some data is missing. And also, whatever is given based on that, let me assume and solve this. They have given that ABCD is a trapezium. AB is parallel to CD. It is given that AD is not parallel to BC. Obviously, for any trapezium, AD should not be parallel to BC. Okay, AB is parallel to CD means AD is not parallel to BC. It is compulsory for a trapezium. Two are not parallel. Both the sets are never parallel. Now they want us to find out triangle ABC and ADC whether they are congruent. ABC and ADC. I hope I have drawn the diagonal and I have marked two angles. What are those angles called? They are alternate interior angles, correct? No? In parallel line properties, we have studied alternate interior angles. Now that is given, one common diagonal is drawn. So you need to find out if there is congruency. They are not congruent because we need to use ASA or SSS or any of these to check whether to find out whether the triangles are congruent. But that is not possible because of the reason that there are three things required for congruency to be established, and we don't see all those three. We have one side common and one angle equal. That is not enough. So we need something else. But actually the question demands something else. So I felt that it is not correct question. But this can be the answer we can give. This is the most appropriate answer we can give. But still not very correct. Okay, let me proceed to the last question. Now, if I trace point SRPQ, what kind of English letter I get? SRPQ. If I take a pencil and draw one line SR, from there again come to P and Q, SRPQ, I get Z shape, correct? No? Z shape. That refers to alternate interior angles. SRP is same as RPQ. Remember, whenever we have such Z shape and the top of the Z and the base of the Z is parallel, their alternate interior angles are equal. So SRP and RPQ, 30 degree only they are. Similarly, if you start drawing your trace from RSQP, that letter will be S. Okay, it will be digital S. So there also this 40 degree is there, no? PQS, that will be equal to RSQ. Above that mark is not there, that angle is not shown. I hope you can draw that. It is alternate interior angle. That also should be 40 degree. Now, students, I want you to learn this seriously because it is very, very useful for your higher classes, and also you will learn so many things. Try to find out many shapes around us. We see already, like there are many like structures in nature also. So you have to find out this, where which kind of polygon, how many types are quadrilaterals you see, whether your tabletop is in the form of trapezium. Try to see, observe properly and list the properties of these trapezium and any other quadrilateral. You will learn so many things. So don't neglect. Okay, learning is, it should be done daily, but mathematics is so much close to life. Huh? It gives a joyful experience, not for just exam sake. You will learn so many other things when you learn mathematics. Okay. So I will end here. Learning properly what is taught is important. Also, don't neglect. Watch the video. Huh? So I will end. There is no other assignment given. Okay, students. All the best in this learning journey.